This is number 24 of the sample final. Tells you there's a cylinder with a movable piston, contains 16.81 liters of CO2 gas at a temperature of 71 degrees Celsius and a pressure of 1.21 atmospheres. If the temperature goes down to -5 degrees Celsius and the pressure remains constant, what volume will the new gas occupy? Not the new gas, the same gas. What volume will it occupy? This is a ratio problem. So you got P1 V1 equals N1 R1 P1 over P2 V2 N2 R2 T2. Now it tells us the pressure remains constant, so we can drop that out. The moles are constant, and of course our R, since it's a constant, is constant for both. So what it ends up being is V1 over V2 equals T1 over T2. Now, the key to these problems are to keep your 1s and 2s straight. I always say that my 1s are my initial and my 2s are my final. So write it down: V1, T1, V2, T2. Now my V1 is what I know initially. It's 16.81 liters. My T1, it goes with that 16.81 liters. So it tells you 16.81 liters of gas at. The key word there is at. At links those two together. So 16.81 liters at 71 degrees Celsius, and that equals 344 Kelvin. We got to have it in that. Our V2 is what we're after, and our T2 is -5 degrees Celsius, which comes out to be 268 Kelvin. So now we're going to solve for V2. When you do, you end up having V2 times T1 equals V1 times T2. So V2 equals V1 times T2 over T1. At this point, you simply plug and chug your numbers. V1 is 16.81 liters. T2 is 268 Kelvin. T1 344 Kelvin. Our kelvins cancel, we're left with liters. Works out to be 13.1 liters. 3 sig figs. This is number 24 on the sample final.